Inflation is a theory that explains what caused our universe to expand during the Big Bang. So, how does inflation work? Well, inflation doubles. This doubling is by exponential growth. This can be represented by 2 to the power of x. 2 to the power of 3 would be 8, 2 to the power of 4 would be 16, and so on. This is why our universe was doubling at 10 to the negative 38 of a second, aka 100 of a trillionth of a trillionth of a trillionth of a second. This is so fast. Inflation was doubling because of negative pressure. Negative pressure increases in volume, increasing its energy, and doubling its mass. We can show negative pressure with a vacuum chamber. If we place a balloon inside the vacuum chamber, it expands. This is because the vacuum chamber removes all air, leaving less pressure and less outside air interfering with the balloon. This shows negative pressure because of negative pressure you expand, and in positive pressure you compress. Within the Big Bang Theory, we had 2 major problems. One of them being the horizon problem. Omnipresent radiation, also known as CMB or cosmic microwave background, was evenly distributed throughout our universe. We measured this radiation and it came out to be about 2.7 Kelvin, also known as negative 455 degrees Fahrenheit. Let's take a closer look at regions A and B. The photons of these regions of the universe weren't able to come into contact because of the rate at which the universe was expanding. So, how is the universe all the same temperature? This doesn't add up. However, inflation solves this problem. At the beginning of inflation, the universe was very, very, very small. The universe was so small that photons were able to mix and react, just like if we were to pour milk into coffee or milk into tea. It takes a while for the 2 substances to react and form one uniform color. Good. Another problem that we had was the flatness problem. We are assuming that the universe is uniform, meaning that we are only limited to 3 Euclidean geometries: closed, open, and flat. Critical mass density, aka the average density of matter, dictates the shape of our universe. So this means that if our cosmological constant, omega, equals 1, then our universe is flat. If we take a look at omega 1 second after the Big Bang, it would have to equal 1 up to 15 decimal points. If omega was even the slightest bit higher than this, our universe would rise towards infinity in 1-th form. If it was even the slightest bit lower, our universe would travel to 0 and also 1-th form. If it was at 1, it would stay at 1. We can represent this with a pin. If the pin stays perfectly balanced, it will not fall. If it's leaning slightly in one direction, it will fall completely in that direction. So why was it exactly 1? This coincidence is frankly unexplainable. Inflation solves this problem too. That is because inflation speeds up over time, meaning that omega could have started at any number. We just need to add more inflation to get to 1. So thank you, Alan Guth, for inflation, and thank you for watching. Bye.